ASA. And yep, you guessed it, that word included is back again, and it's just as important. For the ASA rule to work, the side we know about has to be the one directly connecting the two angles. It's like having two angles and the bridge that runs between them.
But here's where things get really, really clever. Just remember this simple fact. The three angles inside any triangle always add up to 180 degrees. Always. And that simple fact means that if you know two angles in one triangle are equal to two angles in another, well, then the third pair of angles has to be equal too. It's just simple arithmetic.
And because of that amazing little piece of logic, our ASA rule gets a fantastic upgrade. We don't actually need the side to be stuck between the angles anymore. As long as you have any two pairs of equal angles and one corresponding pair of equal sides anywhere in the triangle, that's enough. And this gives us the super flexible angle side or AAS rule.
So let's put this new, flexible tool to the test. Look at this. We have two triangles, AOB on top and DOC on the bottom. We're told two things. Line AB is parallel to line CD, and that point O is the exact midpoint of the line AD. So, with just that info, can we prove these two triangles are identical? Let's see. First, because those lines AB and CD are parallel, we get that classic Z shape. That means the alternate angles at B and C are equal. That's our first A. Next, look where the lines cross at O. Those are vertically opposite angles, so of course they're equal too. That's our second A. And finally, we were told O is the midpoint, which means side OA has to equal side OD. That's our S. Angle, side. The AS rule proves it. They're congruent. Done.
Okay, so we've got these really neat rules. SAS, ASA, AAS. But what's the point? Why does proving two triangles are identical actually matter in the real world? Well, this is where it all comes together.
The truth is, congruence isn't just some abstract idea for a math test. It is the invisible backbone of our entire modern world. I'm serious. Every single factory that pumps out thousands of identical parts, whether it's gears for a car engine or chips for your smartphone, is relying on the principles of congruence. It's the only way to guarantee every piece is a perfect, interchangeable copy.
So yeah, these rules have very real consequences. They're why that new pen refill actually fits. And on a much bigger scale, they're what allow engineers to build massive, stable bridges using countless identical triangular supports. The SAS and ASA rules mathematically guarantee that a triangle is a rigid shape. It doesn't wobble or deform. That's why it's the strongest, most reliable shape in engineering, and it's all thanks to the certainty of congruence. So the next time you see a skyscraper, or a complex machine, or even just a simple manufactured object, take a second look. Now that you know the rules, now that you know the secret code, what hidden geometry can you see shaping the world all around you?